Hey folks, Dan Griffin here, and welcome to the cardiovascular section. We're going to start here with heart embryology by reviewing this table from the book. Now, as you can see, you need to know what each embryologic structure will form. And why might this be important? Well, if you know that the endocardial cushions did not form correctly, then you would know where to look for the defect. And in this case, it would be the atrial septum, the membranous interventricular septum, the AV, and the semilunar valves. So how might this help you? Well, if you're given a patient with Down syndrome and you're told that they have an atrioventricular septal defect, you could memorize that this is commonly due to endocardial cushion defect. Or you could think back to which embryologic structure was involved in creating the atria and the interventricular septum, and that would be the endocardial cushions. Now, as you may already know, there are a lot of different ways to learn the same thing, so just do whatever comes easiest. Now, let's dive right back into this table. The first one isn't too bad here. The truncus arteriosus is going to split to form the ascending aorta as well as the pulmonary trunk. And you can see a depiction of this here. Here you have the truncus arteriosus, and it's going to split to form the ascending aorta as well as the pulmonary trunk. Now don't let the image confuse you here. The pulmonary trunk branches into the right and left pulmonary arteries, and sometimes the pulmonary trunk is just referred to as the pulmonary artery. So once again, the pulmonary arteriosus goes on to form the ascending aorta and pulmonary trunk. Alright, so next up on our table, we have the bulbus cordus, which forms the smooth parts of the left and right ventricular outflow tract. Now this is fairly easy to visualize here, because the central part of the bulbus cordus becomes a very smooth cone-like structure called the conus cordus. And it's this portion that directly feeds into the truncus arteriosus, which, as we just said, forms the aortic and pulmonary trunks. So therefore, the bulbus cordus, which goes on to form the conus cordus, which directly feeds into the truncus arteriosus, forms the left and right ventricular outflow tracts. So next, let's move on to the primitive atrium and ventricle. Now these will form the trabeculated parts of the left and right atria and ventricles respectively. You can see an example of ventricular trabeculations in this image, and the trabeculated parts of each chamber are these large septations of columnar muscle tissue. Now next up, we're going to cover the primitive pulmonary vein and the right horn of the sinus venosus. And these will form the smooth parts of each atrium. And in this image, you can see an example of the smooth parts of an atria. Now to review again, the right horn of the sinus venosus will form the smooth parts of the right atrium, and the primitive pulmonary vein will form the smooth parts of the left atrium. Next, let's take a look at the left horn of the sinus venosus, as well as the right common cardinal vein and the right anterior cardinal vein. You can see here that the left horn of the sinus venosus becomes the coronary sinus, and the right common cardinal vein and the right anterior cardinal vein become the superior vena cava. Now, this is a little hard to visualize, so hopefully this next image will help. So this image here represents the primitive veins of embryologic development, and you can see here the sinus venosus. Now, if we divide the sinus venosus in half, we have a right and left horn of the sinus venosus. And as we stated earlier, the right horn of the sinus venosus becomes the smooth part of the right atrium, and the left horn of the sinus venosus becomes the coronary sinus. And here you can see an example of what the left horn of the sinus venosus becomes, and that again is the coronary sinus. Now above the sinus venosus is where the superior vena cava will come in, and it's made up of the right common cardinal vein and the anterior cardinal veins. And below the sinus venosus is where the inferior vena cava will come in. Now just to help us tie this all together, this structure here is called the right anterior cardinal vein. And this joins with the right common cardinal vein, which you can see here. And these two cardinal veins come together to form the superior vena cava. And what you'll notice here is that these structures empty blood into the right horn of the sinus venosus. And now again, these structures form the superior vena cava, which then, in the adult form, will end up emptying blood into the right atrium, which is what the right horn of the sinus venosus becomes. And that makes sense. So just to make sure we're clear, the right anterior cardinal vein and the right common cardinal vein join to form the superior vena cava. This will empty blood into the right horn of the sinus venosus, which will end up forming the smooth part of the right atrium. And in the adult form, this is exactly what we'd expect. The superior vena cava empties blood into the right atrium. Wow, that was a lot of info to cover, and over a topic that's fairly difficult to conceptualize. The thing to walk away with here is just the basics from the table, and if you need to, you can always come back to review closer to test day. Alright, well that'll wrap up heart embryology. See you in the next video.